All right, so we're going to look at question 770, and we know that we have 40.5 milligrams of a compound that contains carbon, hydrogen, and oxygen. This is taken from the bark of a sassafras tree, and once we do the reaction, we know that we produce 110 milligrams of CO2 and 22.5 milligrams of H2O. And in a twist that we didn't see yesterday, we know that the molecular formula is 162 grams per mole. So as we discussed yesterday and on the previous video, 110 milligrams of CO2, I know that I have 12.011 milligrams of carbon for every 44.01 milligrams of CO2. The milligrams of CO2 cancels, and when I use my calculator, I can simplify this expression. And when I simplify this, I find that I have 30.02067712 milligrams of carbon. So now we're going to apply this to hydrogen. I have 22.5 milligrams of H2O. I know the mass of hydrogen is 1.0079. I have two of those. So that is 2.0158 divided by 18.0152. This is milligrams of H2O. This is milligrams of H. Again, the milligrams of H2O cancels. And when I simplify this expression, 22.5 times 2.0158 divided by 18.0152, I get 2.517624,006 milligrams of hydrogen. Now I can calculate how much oxygen I have. That's going to be 40.5, because that's the total mass of the compound I have, minus 30.02067712 minus 2.5176624006. That leaves me with 7.961660479 milligrams of oxygen. All right, so now what I want to do is I want to convert milligrams of carbon to millimoles. I know there are 12.011 milligrams of carbon and 1 millimole of carbon. For hydrogen, there's 1.0079 milligrams of hydrogen and 1 millimole of hydrogen. And for oxygen, there's 15.9994 milligrams of oxygen and 1 millimole of oxygen. So I'm going to do hydrogen first. This gives me 2.49789067 millimoles of hydrogen. For carbon, I get 2.49943147 millimoles of carbon. Notice that's basically the same number of millimoles of hydrogen that I have. And finally, for oxygen, 7.9616600479 divided by 15.9994 gives me 0.4976224408 millimoles of oxygen. So now we want to divide all of these numbers by the smallest one. Of course, that's going to be the 0.4976 that we got for oxygen. So 2.49943147. I get 5.022. That's good. That's close enough for 5, which means I'm going to get the same thing for hydrogen because those numbers are so similar. And of course, I'll get 1 for oxygen. So my empirical formula is C5H5O. C5H5O. Well, we have one last step. We're given the molar mass So when we compute the mass of this empirical formula, we get a mass of 81.1, basically. I'm going to multiply that by X. And I know that the molecular mass of this compound is 162. Now sometimes this won't make a perfect integer, but when I solve this for X, I'm going to get 2. The specific answer I get is 1.9977, but that's within rounding error. So what does this 2 mean? This 2 means I'm going to multiply my empirical formula by 2 for every atom. So my molecular formula is C10H10O2. Notice the molecular formula in this case is an integer multiple of the empirical formula. Sometimes it can be the same as the empirical formula, but it will never be less than the empirical formula.